First up, we have my boss. So this is Adam.
Hello.
Adam, tell us a little bit about yourself and maybe throw in something that isn't on the slide.
Well, I grew up in South Wales, land of sheep, and moved to the United States. Was a programmer as a kid, wrote lots of computer video games on 8-bit computers. Ended up coming to the United States, working consulting, realizing that in the software industry, testing, requirements management, and a lot of the areas around the life cycle were really hard and not done very well. Thought I'd started a company, and here we are today. And a fun fact, wow. I was a Boy Scout leader, and running the company whilst being a Boy Scout leader can be challenging. I once had to go to a summer camp with a laptop, a solar panel, a battery pack, and a Wi-Fi, and a prepaid iPhone, a whole basic setup just to be able to have connectivity. So I was like one of those like MacGyver Scout leaders who sort of had to keep connected. So that's what the most fun thing I can think of on the spur of the moment.
Awesome. Thank you. And next up, we have our colleague from Curiosity. Hello, Ben. And Ben is based in New York. So, Ben, tell us
Hey.
a little bit about yourself and maybe throw in something that isn't on the slide.
Okay, I have to quickly remind myself what I put on the slide. So I also, grew up writing programs, but I have to admit it wasn't of 8-bit computers. I studied economics and kind of behavioral science, which is maybe a little bit of a departure from usual routes into this industry. And I moved to the States, I guess like 10 years ago or so, 8 years ago, essentially looking at the time at kind of like selling products and building products around testing and test data, which is something I still do today. I've been a product manager, I've been a consultant, and I've kind of been on the solutions engineering side as well. So I guess something that is not on the slide is probably going to be that I think at Curiosity Software, I work with like several former rugby teammates that I used to have as a child.
Interesting. So, natural progression from rugby into software engineering.
Scrum.
It's a classic route.
Absolutely. Scrum.
That's where it comes from.
Exactly. Right. Well, I think we're good to progress on to the core of the webinar, the actual content. So, yeah, this slide is understanding risk. And at this point, I'm going to share a poll because we want to find out from you folks what your understanding of testing time is. So the question is around when testing is executed for your release. And the reason we're asking this, and obviously the slide is about risk, how you manage your testing and the impact that that testing has on further development is obviously something that needs to be planned for in terms of risk. Now, Adam and Ben are going to get into that in more detail, but it would be good to find out from you where in your organization testing sits in terms of the release order structure. Okay, so we've got some results coming in.
Dun, dun, dun.
And still coming in. So the second last one there is taking an early lead. That's when we hit sufficient coverage, code requirements, or both. And coming in second place is the top one, when we hit a sufficient test execution rate percentage or number of tests executed. That's interesting. And then other, we've got a couple of answers for other. And it said, please share in the chat. So it'd be good if you could, those people who posted other, I'd love to hear what that is. And you can post to everyone, or you can, I think you can post it just to the panelists, but it's entirely up to you. But anyway, I'll leave that run for another little bit of time. But yeah, that's interesting. I mean, we've got roughly 60% on the second last option there. So what would you say that tells us about test versus risk?
I mean, it's interesting there. I mean, it looks like people are understanding the idea that you want to make sure you cover requirements, and that means that you have at least every feature has been somewhat tested. There's testing, nothing is missed testing in a complete sense. Obviously, it talks about code coverage, but we don't necessarily know how well that coverage. You might have one test case that's linked to a requirement that covers it at a very surface level or a unit test level. That would still be maybe complete coverage. Is that complete coverage? And then the other thing is you could write 1 billion tests, takes takes a year, and you've covered everything, but you don't have a year. So it's sort of it's interesting, right? That definitely seems to be where you theoretically think the ideal is. But it'll be interesting. But as we get into this webinar, we'll talk about, well, time is finite, and therefore you have to make trade-offs. And applying risk is a way to think about those trade-offs in a kind of intelligent, systematic way, rather than, well, we've got complete coverage, but it might be sort of bogus complete coverage, or we've got complete coverage and we're so late that our product's been superseded by a competitor, which is also a risk as well, not releasing. So it's
exactly,
yeah. So, Ben, any thoughts on that, Paul, before we go into the slides?
Yeah, 100%. So I think the two things that kind of stick out to me are, there's a bit of a kind of people maybe setting down some responsibility, right? So I think people talking about the tests are complete. There's like a presumption there that, hey, the tests are pre-decided, that's kind of out of my hands, right? And it's not a dynamic set of tests that we're either selecting or executing, and maybe it's a finite pool we're selecting from. The second is, I think, when we're like talking about coverage and risk in general, knowing like which risks we're accepting, which ones we're retiring, what are all of the things that were possible? Like, what is our sense of which areas we have designed good tests for or not? I think that that's maybe something that people are trying to look at, but often the best tool we have is some dissection of the requirements that are in front of us. Now, the last thing I'll say about that is that we don't always have the tools to kind of analyze that like more combinatorically as these things get very large.
Absolutely. Yeah, well, with all that said, I suppose it's time to move on to the actual content. So I'll hand it over to you folks. I'll still be here, and but you are taking center stage. So
okay, thanks, Dermot, and I'll take the first section, giving a little bit of background on risk management and risk-based testing. This is a few slides on the topic. I have given a longer 40-minute webinar just on risk and risk management. So if any of these concepts need more explanation, please go to our YouTube channel and the ICON 360 channel, and there are some webinars that actually cover risk in more detail. So, but moving on to just a quick overview, risks are things that happen in the future. Typically, we think of them as being bad things. Technically, risks can be positive things. You can have positive and negative risks. Although if you ever win the lottery, you're usually bankrupt within 2 years. So you could argue that it might be a negative as much as a positive. But in all seriousness, a risk is basically a future event with uncertain outcome that you have to account for and plan, or should ideally account for and plan for. Unlike an issue where people deal with issues and issue tracking, with issues, you're dealing with something that has manifested, something that has happened. At that point, you're in reactivity mode. You're dealing with the issue, you're fixing it, prioritizing it, deciding how important it is. With risks, you have a bit more leeway because you're actually looking ahead to see what might happen. And the idea is try and think of what might happen to prevent it becoming an issue in the first place. And risk management is a discipline, again, which has got a large amount of work with it, and there's lots of tools, systems, and processes, so feel free to research on it. But really, at its crux, a risk management and risks are really all about these future items, and then trying to assess two main factors: how likely they are, we call it probability, and separately, if it happens, how bad it is. We've got some examples in the live application later around finance. And we've got some horror stories. So if I pick a finance example, just to explain it a bit more concretely, suppose there's a risk around one person's bank account potentially being accessible to another person. Now, that's a risk. Now, hopefully the system hasn't been designed to do that, but there's a risk that maybe there's a bug in the security system where you log in, and when you logged in, you can access another account. If that's the case, how would we qualify that risk on our matrix? Well, typically we think of risk, as I said, by a probability and an impact. Now, the probability of that happening, we hope, is unlikely. So it's probably an unlikely risk, but maybe it's a possible risk. Authentication systems do break, a fair amount of the time, so it's possible a bug could be introduced. But what's the impact? Well, the impact is actually catastrophic. Maybe it's critical, but certainly either critical or catastrophic. And so on this risk matrix, it's really on the top two lines, and potentially is in that middle block. So it's actually where that number 1, as you see in the graph today, or maybe one level higher. And that's a risk that you need to really be careful about, because that's something that's going to have a high chance of happening. Not a very high, but it is possible. And if it happens, it's going to be very dangerous to the business. And so that's a risk that you would actively want to try and plan for. And we call those plans mitigations. And so when you start to think about risks, you're basically looking at all of the bad things that could happen, figuring how bad they are by this combination of probability and impact. And the ones that gravitate towards the top right in the direction of the yellow arrow, they're the ones you need to think about mitigating. And just to be clear, it isn't just the one that's in the most top right, the one that's marked as certain and catastrophic. It's almost like that 9 block in the top right: possible, likely, certain, catastrophic, critical, or maybe even marginal. So it's only that top 6 or the bottom 9. So it's really important when you're thinking of risks. Anything in that quadrant, you need to think about mitigating. And how do you mitigate it? Well, there are different ways of doing it, but one of the great ways of doing it is actually doing testing. Because if you can test that the authentication works correctly, and the answer is no, you can't access someone else's account, then, or authorization, I should say, then you've reduced that risk from perhaps possible to unlikely, or even very rare or impossible. And now that overall risk exposure, as we call it, is much lower. Even though the risk is still just as dangerous if it was to happen, you have reduced the likelihood. And so if you take that concept and you look at testing, testing is basically about reducing risk. And so instead of just thinking of all the tests that you could run across your entire test suite, which could be every single UI, API, unit test, functional test, load test, security test. I mean, there's probably more tests that you can run than every single cycle. So if you start to look at risk as what you're trying to deal with, imagine you could figure out which of the tests and combination of tests reduce your overall risk. Now you can figure out which tests are the most important to run. And if you look at this table here, you'll see this is just a way of doing it, where you plot those risks and test cases against each other with other factors, and you can actually figure out, using a risk-based testing approach, which of all my tests in my test plan will reduce my overall aggregation of risk. And I haven't got time to go through all of how that works. I have a webinar on that topic, but just thinking about that, rather than thinking about test coverage around requirements and test coverage around code, which is in the poll, which are both great, think about test coverage around risk. If I have 100 tests, which tests reduce 90% of my risk in that release? And that may be a better way of thinking about it. The next thing to think about is, why is this important in the first place? So that's risk management and risk-based testing at a very high level. We talk about the horror stories. Well, there are many horror stories, unfortunately, in the IT sector, where people didn't necessarily think of the risks and didn't test things adequately. And even though there was lots of tests, maybe lots of testing time, and maybe there were lots of test cases, and maybe they followed all the process correctly, things got missed. What are the outcomes? Well, the most famous one in the UK right now, of course, is the Post Office Horizon IT scandal. Apologies for anyone who working there right now in that industry. It's a horrible story. It's been around since 1999, which is actually the year after I moved to the United States. When I moved to America, I really got into IT. So literally, it spans my entire IT career to some degree, which is scary. They released a system, an ERP system that had many bugs, lots of issues. You can read the detailed technical breakdown: non-atomic transactions, distributed system, lack of audit, things that in an accounting system are generally considered important. And not only did that happen, but then the actual client was able to prosecute people who used the system for fraud. People went to jail, people died. It's a terrible story. It's in the news. You can search on it. But it just shows you the real world impact of an IT failure, of bugs. Literally people dying because of bugs and people going to jail who were innocent. Another example was another famous one from the UK, TSB banking migration. People don't think of data migration sometimes as a bug or as a project. You build the system, done is done, release is done, good to go, drink champagne, go home. That's what they did. They actually have videos of them drinking champagne, not a good look. They went to migrate everyone onto the new platform, and that didn't go so well. And literally, the things I talked about earlier on in my fictitious risk were not fictitious. You could actually see other people's accounts. You could even transfer funds between people's accounts who weren't the same person or in any kind of linked relationship. Someone's wedding money got transferred to someone else. I mean, it was terrible. And you can see there were massive fines. People lost money, reputational damage. I believe this is before GDPR, or it would have been even worse for the company. Again, reputational, financial, compliance, legal, all of those issues. Healthcare, another famous one. This was around integration with back-end systems, built a website to do the Affordable Care Act, healthcare portal, website portal actually was okay. Problem was all the back-end systems couldn't handle the load. They hadn't thought about that. The system basically went down the day it went live. And to this day, it's still, I think, tarnished to some degree the rollout of that whole healthcare initiative. They spent a lot of money to hire experts from Google and other companies to go in there and fix everything. I know some people were involved with that fixing effort. It was incredible, crazy, and again, took a lot of money, created a lot of reputational damage, which I don't think it ever really recovered from. Another major example, more life-threatening, is around energy. Utilities have a lot of IT systems. Most utilities are required to do a lot of testing of their systems, even independently of the application developer. Unfortunately, there was a bug in the system in the control center, resulting in an alarm which prevented a relatively routine failure of a power line, which does happen in summer because of hot weather or cold weather, depending on different times of the year. So routine events that should happen. Unfortunately, in this case, that relatively routine failure became a cascading failure because there was a software bug in the monitoring system. As a result, 55 million customers lost power during, I think it was August, some of the hottest months of the year, where people need air conditioning. Again, life-threatening issue, again, because of a software bug. Another retail example, people think of mission critical as being only in sort of energy and life sciences and healthcare and government. It isn't. Retail can be mission critical, at least for the retailer in question. If retail makes a lot of its money in a very short time of the year. If you don't make money in that very short window, it can be catastrophic with the business. Retailer couldn't basically have its online shopping cart work during the busiest shopping weeks of the year, lost $700,000 in sales in one day. Again, in a low margin business, a single failure like that can be a catastrophic or critical risk, even though it is ultimately a retail company, not what we think of as mission critical, but for them, it is obviously mission critical. And then on the safety side, we often think of things as just software related, but unfortunately, software and hardware can go together. A really creepy, scary example. This was an IoT device that was meant to be given to kids. It was a watch they could use to people could track where they were, and so the parents could locate them. Unfortunately, the authentication wasn't correct, so you could use the APIs even if you weren't the authorized user, allowing other people to check where the kids were, make phone calls, listen in. I mean, literally, terrible app. Effectively, an app for predators and bad people. So again, think of the damage both from reputation for the company and also the potential for harm to the actual users. So as a software professional, I feel that we have to do better than this. Really, we think of software sometimes as just being apps, but really the world's economy and the infrastructure that we rely on to keep the world safe and vibrant relies on software. And as software professionals, I think we have a moral duty to make sure that what we do is as risk-free as possible. I can't say risk-free, but as risk-free as possible, because there's never zero risk. And of course, reputationally, this is no one ever wants to wake up to being in the front page of the Washington Post, whether that's a data breach, power outage, a system outage. None of us want to be in the news. So as professionals, either us or our bosses don't want to be in this position. So again, another reason to make sure we do a good job. So with that, I'm going to hand over to Ben to take up the next section of the slides.
All right. Okay. So when we're thinking about this kind of risk and critical systems in particular, it's worth kind of giving ourselves a little bit of a break, right? So especially when a single failure is enough for the whole project to be a failure, like in that the healthcare example, like lots of different failures, but whether it's, an aircraft or anything else, the issue when it comes to critical systems is that it sometimes only takes one. It only takes one thing. And so if you have risks that are that severe, suddenly the way that you're trying to find things and the level of risk that you're willing to accept is significantly lower. And so that can often take a slightly different calculus as to how deep you have to test and the way that you have to approach it, right? If we're running a website where, maybe our income is more evenly spread across the year, I can fix things in a few hours. Things are more about managing incidents and how fast I can respond rather than preventing every possible incident. In cases where, hey, this chip is literally going to be manufactured like this, it's get it right once or live with a bug for 10 years, it's a different setting, right? So criticality usually comes from how costly is an individual failure going to be, however you want to define cost. So this can be very hard, these systems are often absurdly complicated, right? If you look at, for example, flight software, it can be hundreds of millions of lines of code, you know, absurd complexity. And this is actually going to get, you know, arguably worse when we get AIs and other things involved. Some of these systems have a lot of different possibilities. And just to kind of hammer this point home a little bit, even if you just have, say, 20 true false possibilities that are independent of each other, it's already beyond the realm of testing everything, because that's a million combinations. So the combinatorics of this can often be quite explosive, but that doesn't mean that it's completely hopeless. So when we're thinking about like this huge space of these tests, that's one thing that makes it hard. Designing good tests to cover as much of that space as possible, and you know, at different levels, and prioritizing those are very difficult. But to make it worse, we often don't actually have complete or even good requirements of a system. If my system is going to be hugely complicated, if I don't actually understand the details of what is correct or what risks are out there, then I will find it harder to define and build good tests, to prioritize them, but also, you know, to even understand what risks I am taking, which tests are not built, what things are being deliberately left on the table, right? And when you don't have good requirements, or even if you do, being able to actually systematically measure not just the risks that like come from if certain misses happen, but how big those spaces, how big the gaps in the armor are, is actually quite difficult to do, you know, for typical testing teams. There are tools that can kind of offer some kind of assurance if you know, have them super specifically specified in very specialist cases. If you want to go and, you know, simulate an electronic circuit or something like that, very dedicated tools. What I'm going to be showing you a little bit later today is a modeling approach, which is more generalized for logic in general and software in general. And it also gives us the other benefit here, which is that people don't necessarily agree on how these complicated things are supposed to work. So outside of having, you know, poor requirements or a huge space, we don't necessarily even have agreement about the way they were supposed to work. And so sometimes our testing is verifying the code works as we think it's supposed to work, or that it isn't broken, not necessarily that it's correct in every case. And actually, if we do start to do these massive investments in tests for very complex systems, we can end up in a situation where if things change, and I've written all of these tests and I've done this analysis, that some of it can go out of date quite quickly. So this isn't an easy problem. And I think we can go to the next one. And so just to kind of hammer this home a little bit again, this particular problem, when it comes to how many possible things there could be to test, it's actually a little bit more than exponential, right? Even quite small requirements, quite modest requirements, if you really think about all of the things that could happen and all the ways that users could loop back on themselves, or all the different hardware they could be running on, or, you know, even environmental considerations, how warm is it? There are so many different degrees of freedom here that every one that you add makes it exponentially worse in terms of, you know, testing everything. So that's never been an option. And so sometimes we've looked at, say, just a list of requirements, say, hey, can I have one test for every requirement? Or, hey, have I done all of the 20 tests we all agreed on? What I'm going to say is that there is a middle ground, that we can go somewhere in between that. And we can also assess how big are all of those other cases, and are we thinking about all of the different ones that could vary and how they could vary? So understanding what combinations we're deliberately not covering is just as important as designing good tests to cover the combinations efficiently. All right, I think we can.
Next slide.
Yeah. So what I'm going to be showing you today is Curiosity Quality Modeler. And it is essentially a tool that helps you build models. You know, we can import things that already exist. We can use the AI to help us. I'll show a little bit of that. But these models are essentially representations of some system or some logic or some rules, and how they could vary, how different causes and effects could impact each other. So you could imagine that as, what are the rules for, should I be able to do a transfer between two of my accounts? What are all of the different options available to the user? What's the pathway they take through your screens? What could they do, and what should be the expected result? A formal mapping of that, rather than just a textual statement of it, is essentially what these models represent. And they have two principal benefits building these models. The first is that they act as an unambiguous communication mechanism between us and other teammates, other stakeholders. So, for example, if you write down a flowchart as to how this exactly has to work and all the things that could vary, somebody else can look at it and they can say more easily than if they just look at a set of JIRA requirements, which things that you're missing, but also the specific combinations. Does that work exactly the way that they expected? For example, for users who are of a certain account type, do they have to go through the same approval mechanism when it goes over a certain balance difference between the accounts, right? So building out something where anybody can understand it, but it is unambiguous, unlike the English language, gives us some power to know that we have a handle on this problem. We know what we are and are not considering, right? Maybe we're not going to consider variations on what kind of machines that they use to access our website. Maybe that's out of scope, but understanding that is important. And these models are not just some flowchart on my wall. So what we have behind this in the tool is expert systems that can generate the optimal test cases, or if it's small enough, all of the potential test cases, all of the different pathways through this model, the different things that the user could do, right? So if we go to the next slide, I'll explain a little bit more about that. So in general, these models built with humans and AIs, etc., are a representation of some kind of logic that we have, some kind of system. And we can use that to basically map all of the potential different things that could happen. What the expert tooling can do behind that, the algorithms AI, is select, generate different test cases to cover as many of the different combinations as possible, as efficiently as possible. Taking an example that I had, a few weeks ago, there were 40,000 possible test cases. And by some measures of coverage to the combinations, and I'll show you a little bit of that when we get into the tool, if you randomly generated 1,000 tests, you would not even get over 20% of the important combinations most of the time. And I'm not saying that when we normally design test cases, it's random, but it's very hard as a human when you're writing the 104th test case to consider all of the other test cases you've already built. Computers are really good at that kind of chess game where, hey, I want to generate the best possible set of tests to cover the most kind of combinations, the most parts of my diagram in as small a test set as possible. So in that case there, I was actually able to cover all of the combinations in about 200 test cases of the possible 40,000, where if I just generated randomly, even at 2,000, I wasn't getting close to that number. So computers are very efficient at solving these problems on the one side of this, and that includes generating the automated tests and tagging them up with information so we can prioritize them, like Adam's going to kind of talk about a little bit as well. And then on the other side of it, everybody can go and read this model and actually say, no, that's not how it works. One of the things that's important for any kind of system, critical or otherwise, is that 50% of software defects can actually be solved at the requirement stage because of disagreements. And they often are only found later in testing. Making this visual is one way to avoid that. The final thing that's worth noting about this is that if I can, use this tooling to understand and generate those tests, what it also gives you is a measurement for coverage, which is based on the logic itself. So not based on the code that implements it in like terms of lines of code, not based on the requirements like the original idea, like how it was written, but a kind of more formalized version of all the things that can vary and how they impact what should happen, etc. What combinations of those different things are we actually covering, and can we measure that so we understand the different risks that we're taking, and then generating the different tests we need according to the risk profile that we want to take that release. It doesn't have to be the same every time. The other kind of powerful thing about models like this, and this will be the final thing I'll say about this, is you don't maintain the test assets that come off a model like this directly. What you usually do is you maintain this model, and if things change, or if I want a different risk profile next week, if I have more time or less time, if different parts of it are more important or less important, I can regenerate my tests, I can repair my tests so that I'm not actually going and dealing with that level of maintenance. So I can actually go one level more scientific, but one level more efficient as well. All right.
Excellent.
Okay, so this is just a kind of another example. So the example I'm going to be showing you today, based off a requirement that we have, is that there were 635 possible pathways through this model, and it generated all of those. But actually, when we ran a more like optimized set, like trying to find the best test cases to cover the most of the diagram possible, you could do this in more like a 21 set of test cases. Again, you could export these different sets and bring them into Inflectra and make those decisions later, make them in different settings, but you can actually fundamentally have it generate either all of the possibilities or a more optimal set. But as we kind of discussed earlier, as the number of possibilities, as the number of things grows, eventually you will not be able to test all possible. Right now, I can generate 635. It's not going to generate a billion test cases. So as we get further and further in, eventually we have to optimize, but luckily the computer's very good at doing that. Right. So just coming back to the first slide, and this is the last slide, I promise. If we think about that space of possibilities being very large, our requirements being quite poor, our measurement of that coverage being quite poor, and things changing all of the time, what I'm going to kind of show you in a demonstration in a little bit is how modeling can help understand the space of possibilities and help you measure it, but also help you grapple with that many large number of tests, whether it's kind of componentizing it or just generating large numbers of tests or generating optimal tests when there's lots of possible ones to consider, but also actually getting you on the same page of all of the other stakeholders of this is how this is supposed to work. So you have requirements that are strong enough to actually cover the other way that risks come into these critical systems. All right.
Excellent. Thanks, Ben. So with that is the end of the slides, we promise. So we'll move into live applications. So move it just to quickly. All I did is I clicked on the navigation bar. This is the Spira platform. It has everything from requirements management to testing, test case management, and risk management, and and everything you'd expect in an integrated requirements test and risk management solution. Again, if you want to learn more about Spira, we have other webinars, other demos on our channel. Feel free to look at those. Again, I want to make sure we have enough time to see the modeling. Just to quickly set the stage, however, in the requirements section, we've built out this sample case. I'll collapse that for a second. And we added 3 requirements. As a customer, I want to be able to view the balances of my bank account. As a customer, I want to be able to transfer money between 2 of my own accounts. As a customer, I want to be able to make an external wire transfer to a third party. So these are my 3 user scenarios, user stories, requirements. And if you weren't using modeling, what would you typically do? Well, you would typically go into that requirement and you might go in and create maybe 3 or 4 test cases. So this is an example where we've just taken a human-centric approach of building a minimal set of test cases, some positive, some negative. And how do we do that? In case you're wondering, I didn't do it myself. I used our AI functionality to just generate that. So without any attempt at modeling or any attempt at understanding complexity, as a human, this is what we'd often do, or using a simple AI tool, we would create a minimal set that covers basic functionality, not attempting to optimize or handle complexity. We'll talk more, and this will then be, we'll see the differences when you look into modeling, the kind of real richness you would get out of this. And then we'll come back at the end to look at how the model takes this data and can build something and send it back into the tool. So we're going to start with this requirement, and that's all we're going to start with. And with that requirement built in our requirements management tool, Ben, if you can then take that and show us how we can model that and really delve deeper. So I'll stop sharing.
Absolutely. Let me share my screen. Let me know when you guys can see. Hopefully I share the whole thing. Can you guys see this?
Good to go.
Okay. So I have an elaborated version of that requirement, which has a few more details of some of the things that have to be true. So if I'm doing a transfer between my accounts, someone's written out a basic user flow for me. Sometimes like the transaction limits depends on the kind of account that I am, and there's various things about, different account types. You can transfer from savings to savings, etc., but not from savings to checking. You actually have to have 2 accounts to do this. That seems reasonable, and so on and so forth, right? So I have my kind of different parts of my written requirement here and the kind of user flow. So, they would choose the accounts, they would select the kind of transaction, when they want it to happen, how much money, etc. And there's things about the user that are true, like, what kind of account are they? Are they big, basic, premium business? Are they doing, did they happen to choose savings to savings, savings to checking, etc.? And what were the balances and what were their limits, etc., right? So all of these things essentially determine what kind of message we show to the user. Should it happen? How does it happen, etc.? We probably don't want to allow negative transfers, for example, and so on. So if I want to turn this into a model, which I can go and use to generate my various test cases, I can go and build these models essentially as little flowcharts, right? So I can say, okay, my user logs in, they navigate to the transfer page. How many accounts does the user have? Okay, and I can do a bit of an equivalence class here, right? They have exactly one account, they have 2 accounts, they have 3+ accounts. Okay, well, if they only have one, that's not sufficient. Maybe I should have considered 0, and so on. So pathways through these models, these different decisions, will determine what kind of expected results I should have and what should happen, what variations are possible. Now, rather than just kind of building this as a straight up flowchart, piece by piece, we can also import information that you already have. Now, information that you already have potentially is going to be ambiguous. You might have to refine it a bit. But if I come here to our portal, I can go and import. There's lots of things we can import, including things like code and stuff like that, Swagger specs. But right now I'm going to import essentially a textual requirement. You can import like a Word document, but I'm just going to cut and paste it in here. So if we take that whole requirement that I had, I can actually go and use this to generate a model. And what it's going to go and do for me is analyze this requirement and go and build me a model somewhat like this, although it might have some things I would go and fix up. But it's a series of agents that are talking back and forth to each other to kind of understand and analyze this model, decide what kind of equivalence classes and processes that need to exist in there, and to kind of just give me a little bit of a head start, right? So when this is all kind of built out, and you can go and see how many tokens this will take, etc. When this is all built out, what I'll essentially end up with, and we'll come back to, oh, my screen's gone black for a second. We'll come back and see that in a second. In the meantime, what I'll show you coming back to my model is when I have a model like this with the various pathways through it. So after, they've chosen their accounts, are the accounts actually distinct, right? Or are they not? Did they choose accounts, such that it's an allowed type, right? You can't do savings to checking. All the other combinations like checking to checking, checking to savings, they're all okay. They're actually going to enter an amount to transfer and a date to transfer with, right? So the first question is, hey, is that date in the future? If it's not in the future, we're going to show them a message, and that's the end. If it is in the future, what amount did they pick? Is it too low? Was it above the minimum amount, or was it actually not just above the minimum amount, but actually was specifically equal to the minimum amount, right? And if it's above the minimum amount, was it over the transaction limit, right? So there's lots of different combinations here, and once we actually get to the transaction limits themselves, now we have to make sure we have a sufficient balance, right? So if my balance is less than my transaction amount, if my account type is platinum and I'm in good standing, then we can continue. Otherwise, we're going to end with an insufficient balance notification. If I just never had, if it was equal or I had enough money, then we don't have to go through any of that. After that, are the accounts in the same currency, right? So if they use different currencies, we continue with, we have to show you some fees, etc., which you may or may not accept. And we're going to show you all of those details for the transaction. And then the user might confirm or reject it. If they just confirm it, we go ahead and execute it. If they reject it, they might adjust it, right? Do they adjust it or do they cancel? If they adjust, we have to kind of loop back around here. There's a few times they might adjust it, and we validate it, So a quite simple requirement about transferring between 2 accounts, and there's honestly multiple things I didn't even consider here, has lots of potential ways through it. So the first thing that I can do here is I can actually go and tell the tool to generate me an exhaustive set of test cases. Now, as your requirement grows in complexity, eventually this number will be impossible. It could be billions of potential things. If I go ahead and hit generate here, it's actually going to go and figure this out and solve this little math problem for me and generate all of the different paths through here. So it's found out all of the different combinations it has to cover and all the different possibilities, and it's going to go create me a suite. one of the things that's notable with a model-based testing approach like this is that this model is essentially something that I would be inspecting with all of the other people who would take part in this logic, all of, a product owner, the different people who work on this, etc. And they could actually go and say, well, hold on, is it correct, for example, that we actually just show you the currency fees, you don't have an opportunity to reject them like you do with the other transfer details? Or, well, actually, premium platinum doesn't have to be in good standing. We just go for it. It's silver and gold that will check for that. So these kind of checks are quite easy to kind of spot like this, but for all of the 635 test cases that are possible here, I can kind of select any one of these and like see it highlighted through this model. Now, there are things that you can do to do this with automated testing and with other things like virtual services and test data needs of each test. So I can do something, for example, where, hey, when I'm writing user logs in, I can actually map that to a bit of automation code in a framework of my choice. For example, if I wanted my tests, these 635 tests to all be automated, I can set it up so I'm not going and writing an automation script for each one of these tests, but actually what I'm doing is I'm adding a little piece of automation to each of these blocks on this diagram, and then all of the tests can inherit that. But 635 tests is too many. So the most important thing that we will do here is I can go and say, well, how about we go and take a more risk-based approach? So why don't we start with, say, a medium level of coverage? And I'll explain a little bit about what that means in a second when we go and measure it. So first of all, let's go and generate it. And what the tool is going to go and do is generate me the minimum possible paths to hit the coverage goals that I give it, right? And you can be more controlled with coverage goals. You can cover different parts of the model in more detail or less detail. You can assign different levels of risk. What you realize here is that it's actually whittled this down to 18 paths. So these 18 test cases are actually getting me most of the coverage that I need rather than those 635. And as the number of all possible grows, this will be more and more necessary. So these aren't 18 random tests. In fact, if I go here and hit measure coverage, I can actually see specifically what is and isn't being covered. So I'll just zoom in a little bit so you guys can see. We have 3 levels of coverage, which are basically strictness in terms of how we cover this logic. So nodes just refers to each one of these blocks on the diagram. How much of my logic am I touching? Well, we're touching everything at least one time. That's nice. In fact, each of these lines on the diagram, as in all of the ways any of these bits of logic attached to anything else, we're covering all of those. But we're not covering all of the combinations of all the ways into and then out of every decision. And that's this kind of like highest level of coverage that we track here, which is more of a combinatoric one. And I can actually open the details of this and see for every single bit, like item on the diagram, every combination. So, hey, them logging in and then them navigating, or further down, if we scroll down here, I can see that, okay, them picking an equal, a transfer amount equal to the minimum amount, and then the balance being greater than the transaction amount, that happens in 0 tests. So currently there are risks I'm taking to do with which kind of logical combinations I am and am not covering, but I'm doing pretty well for 18 tests rather than 635, right? And actually, if I want to, what I can do is I can do this and upgrade it to say high and go and hit generate. Now, these tests that I'm creating, it's notable that I can actually go and export these when I choose to. And you can go and say import them into Inflectra. You can go and manage them in in kind of these kind of ALM tools and these kind of risk management tools, these requirement tools. You can also export and attach automation scripts and things like that. So if I hit export on these 22 test cases that we just created together, I can go and export them as test cases, and we can go and say we'll just pick, say, Excel as an example, right? And we can import these this Excel template directly into Inflectra. We're considering a more direct connection, and I can just go and hit execute, and it's actually going to go and package up all of these tests according to this, put them into a file, and hand them over to me. And you can customize the format and that kind of thing. I won't actually let that finish in the interest of time, the last thing that we talked about is kind of focusing in, not just taking a scientific approach to that kind of testing and the coverage, but being able to focus in different places at different times. And one of the things that we have the kind of capability to do here is to tag up each of these blocks. So each of these blocks in this diagram has a lot of information, a summary, description, expected results. It can even have like automation and test data attached to it, for example. But I can also tag it up with like a requirement or a region of my diagram. So here, this is tagged up with bank transfer account. So if I wanted to say generate all of the test cases that touch the, the account type stuff, and then, yeah, okay, this stuff to do with, how much balance I had, I'm kind of less interested in that. I'm really, I have to go through it because it's end to end, but I'm mostly interested in validating this at different levels of risk. Hey, if you go over a balance requirement, that's a smaller deal than if we put it into an account that doesn't exist, right? So I'm taking this kind of risk-based approach when I'm defining how I want it to optimize. I can actually go and say, well, bring in all of these like requirements that I have. So about the account type, the amounts, the currencies, the UI requirements, the dates requirements, bring all of these in, and then I can give them different levels of coverage that I want to say. So I can say, hey, you know what? For this account stuff, I want it to be exhaustive. For this amount stuff, you can ignore it. As in, hey, no points for covering this, but if you happen to cover it, great. And for this UI stuff, you can put it on a medium. So I can actually make these decisions last minute and just go ahead and hit regenerate and go and export again. And the same thing is true if we change the rules, and then I'll hand it back over. If, for example, now we say, you know what, Platinum, actually you can just go straight to checking the currency, and Gold, you know what, you are the one that we're going to allow to check if it's in good standing, and Silver, you just continue as you did before. If I go and hit save now, having made these changes to my diagram, if we think about those original test cases I have, the classic problem is which ones can I throw away? Which new ones do I need to kind of absolve this risk? What I can actually do here is if I go and look at my test cases, it's actually showing me that several of them are invalid because of what I've done. If I want to, I can go ahead and hit repair. It will fix up my test cases. And I can actually go, and after fixing up my test cases, I can go and measure their coverage and see, okay, I've lost a little bit of coverage here because of the new combinations that are created that are possible. So I'd actually like you to go ahead and improve the coverage, and it will run an optimization which is purely based around bringing these numbers up to 100% with the smallest number of tests, but keeping these 18 as they are, so that if I'm managing my risks and I'm having people, build things to those tests over, say, on the other side of things, then I don't necessarily have to go and redo and rebuild everything.
This was the requirement we first started with. And as Ben mentioned, we were able to, using the modeling tool, you can build out lots of more detailed requirements. For example, here's the user flow that Ben took. And when you generate those test cases, we haven't yet got a live integration. So you can just use our Excel import tool, take those generated test cases that Ben generated, import those back into Spira. And then what will happen is all of those tests get mapped to the different test cases, to the different requirements, sorry. And then they will all appear here in the test repository in Spira and can then be executed both manually, but also, as Ben illustrated, they can generate automation scripts which can be pushed into an automation tool like Rapise or any of the other automation tools that we integrate with. And the last thing I just want to show very quickly before we go over to Q&A, sorry, this is in the way. Yep, is that for each of those requirements, we're also able to use the AI functionality or, again, human functionality in Spira to generate the risk associated with it. So with that one transfer requirement, in the background, I used our AI functionality to identify about 10 common risks. And you can see them all here: integration, compliance, performance, security, a whole bunch of different risks. I do that for all the requirements that are generated. I link these to my requirements, and I can then run a risk report. And that's going to take the requirements that we push to the model optimizes those, and then we can link those to our risks we've identified as well. And now we get an analysis of what's my risk exposure. And you could regenerate the test cases in the Curiosities platform, push them back into Spira, rerun this report, and you'll now see what is my risk exposure that my test cases are reducing. So you get a dynamic qualification of not just how much test coverage from a requirement standpoint or optimization. I can even tell you in a numerical quantitative way how much risk have I reduced, and therefore you can war game in in the modeling tool, and then run the report in Spira to see live what is that overall reduction in risk. Again, we can spend a lot more time going through this it's click by click, but I want to make sure we have time for Q&A. So with that, Dermot, can I hand it back to you for Q&A?
Absolutely, with pleasure. So I'm just going to share the results from the poll. That'll be up while everybody's interacting. We have a couple of questions that have come in. Ben has been good enough to answer one of them directly in the chat. We've one from Carol who's saying, can we not just use methods like code coverage, decision tables, or all pairs to ensure sufficient testing?
That's a great question. So there's two ways of looking at that. So if you think about, say, all pairs as an example, and then code coverage is another example. So all pairs, for example, is a good technique for problem spaces that can be broken down into degrees of freedom that you can pair up as many of them as you want. If you think about the model I was showing you, you can think of it as a very heavily constrained all pairs in the sense of, some decisions you take down that model will completely mean you don't have to even consider many of the other combinations. When you do that with a traditional pairs technique, you have to write dozens and dozens of basically constraints to stop those pairs being considered. The other thing is that the model doesn't just offer you an all pairs point of view in terms of generating tests, and this also speaks to the code coverage side, which is the other half of this problem is making sure you're testing the requirement as it's supposed to be, as in how it's supposed to work, not how it is implemented. So with code coverage, there's a few issues with different types of code coverage, like do you go down to like a clause level, every single Boolean, is it true, false? But covering 100% code doesn't mean that that code is correct, it is doing the right thing. So that's usually the problem with code coverage, and it certainly doesn't necessarily help you. I would view code coverage as like a necessary but not sufficient condition.
Yeah. Absolutely. And I think we've time for one more quick one from Surjit. Can Spira integrate with third-party applications?
Yes, Spira can integrate with various different tools, including our own automation tool, also various other automation tools. So if you're generating scripts in Playwright, Selenium, Appium, Cypress, we can do that. Also, back to code coverage and code quality, we can also ingest code from Git repositories, even Subversion for those using older tools. And we have integration with a lot of the CI platforms like GitHub, GitLab, Circle CI, AWS Code Commit, Code Build. So as a platform, it really allows you to take not just requirements and risks, but also integrate it into your DevOps tool chain. At the same time, haven't time to show today, you can take all those project level data, roll it up to a program or portfolio. So when you're the CIO and you're looking at, well, what does that risk mean for me from a company risk? I can actually plan out across all my 10 different projects, which is the highest level of risk. Do we need to actually do a management level intervention to figure out the team has accepted too much risk that we as a company cannot? So you can even start to say, this is our highest priority program. Therefore, my risk tolerance for that program is much lower than a program that if we're a month late or if there's some quality issues, it's less critical for the business. So it lets you think of risk not just at a technical level that we talked about today, but also it elevates you up to a program level as well. So we have program level functionality as well as obviously the integrations with different tools at the DevOps CI tool chain level.
Absolutely. All right, folks, I think with 1 minute to go, that's the time to wrap it up. I would say for any other attendees who have questions, the best thing would be for you to reach out to us. So you can contact either Curiosity or Inflectra. You can access us on our websites, and you can contact us directly if you have further questions about either Spira platform or Curiosity, and we can continue our conversations offline. But in the meantime, and until the next webinar, thanks everyone for your attendance and your attention. Thank you to Ben, thank you to Adam, and have a great morning, afternoon, or evening, depending on where in the world you are.